So, friends, welcome to this lecture series of geomorphology, and in the today's class we are going to discuss about the landforms in dry region. So, if you remember our earlier discussion, we are talking something about the dry region in which there are certain characteristics features. First is it should be less rainfall, or it is the evapotranspiration is more than precipitation. Second thing, that the streams should be ephemeral and there will be water loss from upstream to downstream. And third is the soils has to be, pore space of the soil has to be filled with secondary salts, or the salts which is coming from this evapotranspiration of this water. And the dry region is also characterized by gravels and rocks, which is frequently transformation of landform, and frequency and intensity will be more. So, with these conditions, let us discuss about the landforms in the dry region. So, the first and foremost landform in the dry region is the desert plain and plateaus. The greatest portion of this world arid region are monotonous plains and flat. The plateaus are in the interior of this continent. For example, if you see this photograph, these are the plain areas, these are plain areas, and here the plateaus, the mountains are there. So, most part of this arid region are flat plains, and these plateaus, they are at the interior part of this continent. However, this is very interesting here to mention that there is no compelling reason why dry regions should be non-orogenic. There is no reason for that. Orogenesis and dry region, two different things. One is external, another is internal. But here we have to understand that the non-orogenic regions are likely to form large interior part of the continent where moisture bearing winds cannot penetrate. Second thing, that the non-orogenic regions are lack of relief necessarily for orographic precipitation. Here 3 points are there, you have to understand here. First is the non-orogenic region, that means lack of mountain building activities. So, that means relatively tectonically stable regions. So, once we have relatively tectonic stable regions, there is new tectonic movement. So, relief will be low, erosion and weathering process will dominate, it will come down its relief to lower level to make it plateau. So, once it make it plateau, that means there will be no orographic precipitation. Orographic precipitation means, suppose we have this water vapor laden wind, it is moving and it is hitting the mountain system, it will move up, it will cool down and will precipitate here. So, this is called orographic precipitation, but it is plateau, flat lying body. So, there is no hindrance to this wind to move. So, that is why there is no question of orographic precipitation. Second thing, that once it is lying inside, there is no orogenic process, no renewal of the orogenic process. So, only the removal is, no material is added, only removal is dominant. So, in that case it makes it flat and plateaus. So, that means orogenic, non-orogenic regions, they are mostly governed by, or that is mostly characterized by formation of plateaus, and as these are, if these places or these non-orogenic places, they are lying in the interior of this continent, here the moisture laden wind, they cannot reach up to that distance. So, that means that is why mostly this region which is arid region are non-orogenic. In addition to that, desert elevation borrows minor relief. Even if there is minor relief exists, but desert elevation, this sedimentation of the desert, mostly it is by wind. They bury these minor reliefs, and this burial and exposure is a frequent change, because wind sometimes it buries here by sand, sometimes the sand will be again removed to somewhere else. Wind has been suggested as a leveling agent in the desert plains. If you see here, this is the desert plain, and these are the wind blown activities, the ripple marks, wind ripples, and this total system is composed of loose sand, which is frequently transported, deposited and redeposited, reworked by the wind activity. Wind increases desert relief by excavating basins and constructing major dune landforms. It is very important to understand here. Wind is increasing desert relief. For example, suppose in this particular photograph, if you consider, here is a depression, it is called deflation halo or so, and here is the dune. Now, this relief difference will be somewhat, suppose like this, is not it. So, now if again wind works, again it will remove the material from here and deposit here. So, the relief increases, and it is not true that always relief will increase. So, that depends upon the frequency of wind transportation and deposition. It may happen during the reverse wind direction, this material will be transported from here and deposited here. So, that means it is a constant change. It is not always true that wind will increase the relief. There may be a relief penetration, there will be change in relief, frequent change in relief, frequent change of landforms, that is found in the desert region. Where alluvial fonts merge in the desert basin, a saline lake playa may form. Here mud and salt accumulate to form the most leveling topography on this desert surface developed on the earth. So, suppose we have playas. Playa, that means this water, it is rich in salts. So, in mud and salt there will accumulate, salt will precipitate, mud will accumulate, and combinedly that will form a flat topography. Sometimes you might have seen in TV screens that this type of topography people used to play in playground or some racing grounds. So, this is the most leveling topography. This is due to this combination of the mud and salt together, and mostly it is formed in the playas. Evaporation from playa creates mud cracks and salt cracks. It is characteristics of dry region and dry climate. If you see here in this photograph, they are the salt cracks. Similarly, mud cracks we know they are characteristics feature of arid climate, arid region, but these playas of dried region and playa of semi-arid region have different characteristics. So, we have to think upon, depending upon the playa characteristics, what type of topography or what type of climate or what type of paleoclimate we are dealing with. A variety of desert process produces a surface concentrate on gravel called REG, reg or stony desert. It is, there are three types of desert, one is stony desert, one is sandy desert, one is total rock body, that means total plateau, rock exposure. So, here different type of desert processes are involved. So, those different types, what are the different types we will discuss here. Now, one characteristic feature of this accumulation of these gravels, that is called desert pavement. Desert pavement may form a stable flat surface mosaic of closely filled cobbles and pebbles in a layer only 1 or 2 rock deep, each polished by sandblast and often faceted as well. Here if you see this photograph, the first photograph here you see we have mixture of sand and gravel, and once we allow the wind to blow on it, it will blow off the sand, the finer particles, the silt and clay particles. However, the remaining will be rich in these gravels, and after few years or few months or so, now you see the top surface is concentrating these gravels. The gravel population is more as compared to others. So, the thickness of this plane, the rock plane or this pebbles and cobble plane, it is about 1 to 2 pebble or so. And very interesting thing is that here they are highly polished and sometimes often faceted. Faceted means one particular face of a pebble or a gravel or a boulder, it will be cut plain by the constant bombardment of sand particles on that face. So, that indicates the direction of wind transport, direction of wind flows. So, rock varnish create coated clast, rock varnish is creating coated clast, the clast will be coated. So, how it happens, how this, what is the mechanism of coating, we will discuss later times. Now, here is the mechanism is elaborated with this help of figure. Now, see, suppose we have a block having mixture of sand and gravels and we allow the wind to blow on it. So, here with time in this axis it is increasing time, here you see with time the number of gravels they are increasing on the surface. In this figure we have less number of gravel relative to this figure. Now, you see the number of gravel is increasing and the height of the block is also decreasing. That means, the sand silt clay size particles from the surface that is blown out due to this wind action. And finally, if again it is allowed to continue, after few times later you will find that the surface it is concentrated with the boulders, the pebbles and cobbles or the larger fragments, and the sand is totally wiped out. So, this thickness of this part it is about to 1 or 2 boulders or so, and this is called desert pavement. If wind abrasion is not severe, then rock varnish may coat. It is very important here. Rock varnish and wind abrasion, they are two opposite things. So, abrasion is more, the polish will be more and no coating will be there. And once we are getting the rock varnish in a desert, so that means we can interpret here wind abrasion is not severe, it is not effective. So, may coat rock varnish may coat the exposed surface of the pavement. If rocks have been moved, their varnish free under surface betray the movement, so animal trails and vehicle tracks across the edge remain visible and decades to continue. Now, if you see here, you might have seen in a TV some Discovery Channel or somewhere, these people of ancient times, the Stone Age, they used to make some art in this rock varnish and they are still remaining now after thousands of years. So, here the rock varnish, this is called rock varnish, that is a coating of iron, manganese or the mixture of that, the coating that is on the surface. So, these are the arts of the ancient people, ancient civilization. So, that can be stored and it is stored or preserved in the desert rock for hundreds of thousands of years. That is called rock varnish. This coating is called rock varnish. So, the color of this coating that depends upon on which material it is coated. For example, if you see here, this is mostly dark red color and it is somewhat brown or yellowish color. So, this compositional difference will be there. And now that people are using the rock varnish to date the time of this art and when this art was being drawn and what is the time of that people who are staying there. So, that can be used based on the dating of this rock varnish. It is a separate part of the story. Not only this deflation that can cause the development of this desert pavement, there are other processes also which is responsible for formation of or the possibility to form this desert pavement. For example, sheet flood and channel flow during and after storms. can score away the finer sediments, and the remaining surface will be rich in these boulders. So, it will called desert pavement. Second thing that, or the third thing, it is the freezing and thawing, wetting and drying. So, we know in our earlier classes the creep is the action when there will be freeze or thaw, or there will be heat and release of heat, there will be expansion and contraction. So, during expansion the material is coming up. So, once the material is coming up, suppose we have boulders, pebbles and cobbles, they are coming close to the surface. The gravel size particles, they move upward to accumulate near to the surface layer above the substrate, and it forms the desert pavement. So, there are many mechanisms to form the desert pavement. However, the wind deflation is the major process to form the desert pavement on the plain. As aeolian dust accumulates on the desert landscape, it can filter out down through the gravels to form pedogenic horizon beneath the desert pavement. Now, see, we have desert pavement, that means it is accumulated with boulders, pebbles, cobbles. We have pore spaces through that, very minute pore spaces. So, now below is we have sand and gravel mixture. Suppose there is dust falling down. So, the dust that will through these pore spaces, through these gaps, that will move down and will promote formation of the soil, desert soil. So, approximately 1/4 of the Sahara and Arabian desert are sandy areas or org. So, rocky area, that is called REG, that is rocky areas, and sandy area, that is called ERG, urge. So, the remember is either hamada or reg. Hamada means only the rock body is exposed. So, rock body exposed if is there, that is called hamada, that is then boulders, pebbles, cobbles dominated, that is called reg, and if it is sand dominated, that is called urge, ERG. So, here these three categories has been defined with the help of photographs. Here this you see sand dunes, sand dominated, that is urge. Then here that is see clast dominated, the fragments, the pebbles, cobbles, boulders dominated, that is reg, stony plain, also called desert pavement. Then hamada, it is flat sandstone plateau. See, these are the flat plateaus, it is hamada. It is not necessarily it should have sandstone. For this particular photograph, it is for the sandstone. Sand cover less than 10% of the Sahara. So, that means you see Sahara, the largest desert in the world, it is sand cover less than 10%. So, that means the remaining part it or the 90% or more than 90%, it is due to this hamada and reg. Rock ledges are pitted and polished by abrasive windborne sand, but the dominant relief is fluvial. That is very important to understand here. Though we are talking that the desert is dominated by wind, it is the loose fragments which is frequently moving here and there, changing the landscape frequently, but if you analyze the dominating landscapes of this world, arid zone landscapes in the world, you will see that the dominant relief of this arid region, it is governed by the fluvial process. Even if nowadays, if you see this present day Saharas and these Kalaharis or whatever these deserts are there, maximum relief difference or this geological work carried out by fluvial process is dominating rather than this windborne process. So, that means I want to say those regions earlier it was dominated by fluvial processes. Fluvial process was active in modifying the landscape. Now, due to climate change, those are converted to arid zones and the wind is now continuously modifying the earlier remnant fluvial processes. So, that means that is why it is called the dominant relief is due to fluvial erosion or fluvial work. Some channels are used by present runoff. Even if the rain is less than half or only 12 months, but an unknown portion of this desert dissection is probably due to by this formerly greater runoff. So, that means you see these are the photographs, this is the ephemeral fluvial flow, similarly ephemeral playa lakes, then branching linear dunes, whatever the limit of fluvial penetration. So, deep interdune ponds, the fluvial lacustrine delta. So, that means here though we believe and we see this wind is frequently changing the landscape in the arid region, but this dominant landscapes of this arid region, it is governed by the present or this is annual or that is whatever the once upon a time this fluvial process or the ancient fluvial process. Though that means I want to say even if there is very less raining once in 12 months or once in a 24 months, but that once that will change the landscape to much extent as compared to this changes by wind. So, though wind frequently changing the landscape, but the intensity of change is dominated by or it is governed by the fluvial processes. Most arid landscapes are essentially fluvial. See, mostly arid landscapes is essentially fluvial. So, that means here it should come in your mind that though rain is deficient, precipitation is deficient even if less than once in 12 months, but that once that affects more as compared to the frequent effect or the continuous effect of wind. Now, see these photographs, these are the fluvial systems, this river is flowing, this is fluvial system, it is fluvial flow directions. So, fluvial river is flowing that. So, this landscapes once upon a time it was dominated by fluvial process. Nowadays, though raining is restricted once in a year or that once is dominating more in landscape development or penetration or defragmentation of the landscapes rather than this wind. So, let us start with the mountain deserts. Mountain deserts, the desert basin and range province in southwestern USA, the Mexico, the Pacific coastal deserts of Chile and Peru, and the thin skinned fold mountain adjacent to the Persian Gulfs, each of the example of mountain desert. Now, you see these imageries, the photographs, see these are the basin, range and province. So, it is an extensional basin, extension is going on here. You see there are thousands of gravens and hosts. Similarly, this side the Peru and Chile, whatever this desert is situated here, and around the Persian Gulf we have deserts. So, these are dominated by mountains. So, that is why it is called mountain desert. So, desert which is dominated by mountain areas. The area of this mountain desert, they are small as compared to this continent size deserts of Australia and Sahara, and the desert plains of Arabia, Transcaspian, Caspian, former USSR and western China. So, though we have these mountain deserts, but their area is small, they occupy small area as compared to the other desert like Saharas, Kalahari's and other USSR and China's whatever the cold and hot desert. So, these mountain deserts, they are in small area. The common landforms of intermountain desert is the alluvial fan. So, that means intermountain, this intermountain area is called intermountain basin. So, this intermountain basin, suppose for example, here you see this is a mountain range and this is mountain. In this area this is called intermountain. So, this intermountain area, it is occupied by alluvial fans. Alluvial fans, that means these channels which is coming out from here and the channels which are coming out from here, they deposit their sediment in this place and this place, these are the alluvial fans. So, number of alluvial fans, they are restricted within that intermountain basin. The great apron of coalescing fan at the mountain front is called Bajada or Bahada. So, we know it in the geomorphological term. Bajada, it is the coalitions of alluvial fan. For example, here we have alluvial fan, we have alluvial fan, we have alluvial fan. So, That means, by coalescence of number of alluvial fans, it forming a fan province, that is called Bajada or Bahada. Interflow rivers decrease in discharge as they enter desert basins and deposit their entire sediment load as they spread laterally, evaporate and infiltrate. Desert mountains are progressively buried by their own waste. For example, if you see here, we have a alluvial fan here, we have a alluvial fan here, we have a alluvial plain here. So, by combination of this, we say it is a Bajada. Now, you see, once this alluvial fan forms, so at the foot of this mountain, they bury some part of this mountain from which they carry the sediment. So, for example, here, so this much part of this mountain is buried under this fan. Now, suppose we allow this fan to grow, further addition of sediment. So, that means the fan will be of this much size, again this much, the fan will be of this much size, this fan will be of this much size. So, that means these fans, they are continuously burying those part of this mountain from which they form. So, that is why it is said the desert mountains are progressively buried in their or by their own waste. When waste means, for in this case waste is called sediment. Then after the desert mountain or mountain desert, the most interesting and the most important part of this arid region, it is called pediment. Pediment and Piedmont, by listening it seems same, but the difference is Piedmont, it is a depositional process, Piedmont is a depositional feature, accumulation of feature, but pediment it is erosional, removal feature. Here the sediments are removed by erosion, but in Piedmont sediments are deposited. Here Piedmont is a plain which lies at the foot of mountain in an arid region or in the headwater basin with the mountain mass. The name is applied because the plain appears to be a pediment upon which the mountain stands. Here if you see this model is given, this is the pediment surface, that means erosional surface, that means it is a gently sloping plain through which erosional scars are there and material is being removed due to water action, due to this ephemeral stream during raining, and this part, this gentle sloping plain, it is sometimes covered by gravels. So, this is pediment, and if you look from a distance, you may see that this is a flat surface and here a mountain is standing. So, it looks as if the mountain is standing on the flat surface or this flat surface behaves at the basement of the mountain. So, that is why the term was coined there. The name applied because the plain appears to be a pediment upon which the mountain stands. So, now if you see this figure, this is the mountain and this is the flat region, and here this region is covered with sediments, gravel. So, this is called pediment. So, pediment means it is an erosional plain through which the sediment is being transported from this mountain to the plain region. So, pediment is formed by erosion and deposition of streams, usually of ephemeral types, and is covered with thinner gravel transferred from the higher to lower level. So, sometimes this part it covered with gravel, very thin gravel content, very thin gravel apron will be there. So, pediments has no relations to pedestals, with which it is frequently confused, or to be the very general descriptive term Piedmont, which is simply at the foot of mountain. So, here Piedmont is a depositional feature and pediment is an erosional feature. So, this term pediment was first used by Gilbert in 1882. The term pediment was casually applied to the surface of alluvial fans that encircle desert mountain. But Bryan's definitive study followed McGee's observation in the same general area emphasized that pediments are slopes of a transportation cut on the bedrock usually covered with a veneer of alluvial or transit from higher to lower level. Here it has to be understood for pediments are slopes of transportation through which the eroded sediment from this hill that will be transported to the plain area to the nearby alluvial fans. So, that means the alluvial here is the mountain, here is the pediment and here is the alluvial fan. So, this region it is a flat region or gentle sloping region through which the sediments eroded from this mountain are being transported through ephemeral streams and deposit at the mountain front that is on the alluvial fans. So, this is the difference between these two. So, usually covered with a veneer of alluvium, thin alluvium cover in transit from higher to lower level. By original definition and conventional use, the pediment is a landform of a dry region. Earlier when this term was coined, those slopes, the transportation slope, gentle sloping transportation slope along the hillside of a dry region was used or defined to form this pediment. But later its term, this circle of this term, the application of this term was extended, the word has been applied, and gently sloping pediment, erosional surface of low relief in climate ranging from subpolar to humid region and tropics. Wherever tectonic stability has permitted erosion and transport to become balanced for a long enough time to develop an extensive surface. Here it has to be understood here that it is a tectonic stable region. Why? If it tectonic unstable, then there will be frequent change in topography and there will be no gentle sloping region exist, because tectonic will change this topography. So, pediment development itself indicate indirectly that the region is a tectonically stable region. It is a plain, there is no climatic boundary, it is a gentle sloping plain in a tectonically stable environment used for transportation of material, or it is behaved as a transportation slope. So, this transported material through this gentle slope, it moves down from higher to lower level and deposited in the nearby alluvial fans by the ephemeral stream. And this gentle sloping surface, sometimes it is covered by boulders, pebbles and cobbles. So, thin sedimentary cover sometimes it is upturned with. In form and function, a pediment is similar to a alluvial fan, and the difference being that the pediment is an erosional landform and fan is a constructional. Now, if you see here from the top you can see this is an alluvial fan and this is a pediment surface. This is a pediment surface, this is alluvial fan. So, by form and function both are looking similar, that means close to mountain flat, at the base of the mountain, here sediment is deposited, but here sediment is eroded. That means, if we want to create an alluvial fan, it would be here, and the alluvial fan we have playas. So, the slope of on pediment as on alluvial fans increases from this part to this part, that means close to this mountain front the slope of the pediment is more. So, it is a gentle sloping surface like this, here the slope is more, here it will be less like this, and the slope varies from 1 to 7 degree. At the base of the fault scarp or at the sharp erodibility contrast between mountain rock and those of this adjacent basin, the head of a pediment may be quite linear. On other pediments, the pediments extend well into the mountain mass and board embankment, leaving extremely sinus mountain front. It is has to be understood here. Suppose we have a fault scarp at the mountain base. So, after that fault scarp or along this fault scarp, the pediment will be straight, okay. And sometimes the pediment surface it extends towards the mountain. Suppose for example, here is a lobe, mountain lobe, and here is a mountain lobe. Within these two lobe there is a pediment surface, it is extending inside this mountain, and sometimes this extension from all sides or extension both side it isolate a lobe here, a mountain, a nose here, isolate a nose here. So, headward portion of pediments may penetrate into the mountain mass, isolating segments of the range and possibly intersecting with pediment from the other side, and range in pediment it is called the pediment pass. So, here suppose in this figure it is given, suppose we have a pediment surface here, it is growing inside due to erosion and erosion. Similarly, a pediment surface here it is growing inside due to erosion. So, a time may come due to extensive erosion, the pediment from this side and pediment from this side they will interact with each other, they coalescence with each other. As a result, this part of this mountain that will cut off from the main mountain body, and this is called pediment pass. This joint of pediment from other side of the mountain to this side of this mountain. So, this is called pediment pass. So, through this pediment pass a part of the mountain will be cut off from the main mountain body. So, there are no significant differences in slope, roughness or size between alluvial fan and pediment. The pediment form like that of alluvial fan is an excellent example of water spreading wash slope. Water spreading wash slope, if you can remember when talking about slopes, some of the slopes they are water spreading slopes, some of the slopes they are water accumulating slope. So, these are the function of contours, they are a function of slopes, convex slope, concave slope and contour. So, combination of this contour design or slopes design, this water spreading and water accumulating slope has been identified. So, this pediment they behave as water spreading slopes. In plan view, pediments like alluvial fan range from semicircular flat cones to a series of shallow gently concave valleys. If you see here, we have alluvial fan and we have pediments. If you take a cross section, both will like this concave of slopes, and this is behave as a water spreading slope. Formational zone of pediments here, 3 formational zones are recognized for pediments. In pediments, 3 zones has been classified. One, an innermost zone of mountainous uplands that have near vertical erosion, an intermediate zone which is the pediment beyond the mountain front, and the outer zone which extend beyond the pediment and is a zone for deposition. That means, the third zone or the outer zone it is a transition between the pediment and this alluvial fan. It the deposition of the alluvial fan starts from this outer zone of this pediment. Functionally, it is an ideal surface to distribute and dissipate a mass of water and sediment introduced at the apex. So, here if you see, suppose we are creating a pediment surface, we are pouring water here with sediments, this will come and finally, it will spread here. So, that means alluvial fan and pediment both are in form and process both are same. However, alluvial fans are depositional sites and pediments are erosional site, and this eroded sediment they will deposition started from here. So, this is the outer zone, this is the middle zone, this is the inner zone. So, 3 zones of the pediment has been classified. So, coalitions of pediments over large area results pediplains. Like coalitions of alluvial fan, it is called bajada or bahada. Similarly, the pediplains or the pediments they coalescence with each other and forming a planar topography that is called peדיplanes. So, as the pediment expands into the mountain slopes, the lower part of this pediment in turn may be progressively buried by the aggrading bajada or alluvium. So, as we have discussed so far that the third zone or the outer zone where the alluvial plain starts. So, once the alluvial plain grows, some part it will cover some part of the outer part of this pediments. For this reason, pediments in truly arid region where the local base level is a playa are generally only narrow rock cut fringes between mountain fronts and the bajada. Because if the base level will be far away, sediment has to be transported more distance. But if base level is here, for example, in this particular case the playa is the base level. So, sediment has to be deposited here. So, more and more sediment accumulation, so sediment will move in this upstream direction. So, part of this pediment will be covered with this sediment. That is why in those areas, the intermountain basins where playas are there, the thickness or the width of this pediment will be very less, because much part of this pediment will be covered by these bajadas, these alluvial plains. So, this is all about the pediment. I think we will discuss in the next class. Thank you very much. Thank you again.